So again, a bit of a long title today, translating expressions, equations, and inequalities. So there's going to be basically 3 distinct sections of today's notes. We're going to have expressions, we're going to have equations, we're going to have inequalities. And so what I'd like to do first is just build up a word bank or phrases, words or phrases that mean each of these things here. So somebody tell me, what is a word that we use for addition? What's a word or a phrase that we use for addition? Add, yes. And I'm just going to put that right up here in parentheses and put add right up there. Okay, what else? What other words do we use for addition? Maybe read through some of the examples on the first and the second page and see if you can pick out anything that means add. Miranda? What's that? Greater? Greater actually is going to be, I like the thought, if something is greater than something else, you can think of that kind of as addition, but greater means something is more than something else, and that is actually going to apply to our inequalities, and we'll definitely get there in a little bit. How about, so if we say, so greater than implies the symbol, but the other way of saying greater than could be more than. More than would imply addition. And I know that greater than and more than, they kind of mean the same thing as we're talking, but in terms of how they translate to mathematical symbols, more than is pretty specific to addition, greater than is pretty specific to like the inequality symbol. So what else do we use? Sum, yes, sum, S-U-M for sum. What else? We got 3 more that we're going to use. See if you can find them in those examples. What are other ways that we can say addition? Yeah. Product is actually going to be with multiplication. So let's go ahead and do that. So product is a multiplication word. So we'll fill that in for that one. What else for addition though? So we got more than, we've got some. So while you're out of the room, Miranda said greater, and greater than is actually going to be one of our inequality symbols. It's one of the, greater than or less than. And as I mentioned that, as we're just like speaking, if you're talking to somebody in a conversation, you say something is for greater than something else, that means adding. But in a math context, more than is going to mean plus, greater than is going to mean that symbol. So it's the wording, I guess, language-wise means the same thing, but math-wise means something a little different. So I would agree in almost every scenario outside of a classroom, but inside the classroom, greater than is that symbol. What else? What do we call that symbol? What is it? Plus, yeah. So plus, that would definitely be. Let's see, we got 2 more. L? What's that? Increased by, yeah, increased. Yes, so if you increase something by something else. So increased by. Okay. And then there's one more, and I'm going to see if I can find it here. No, it is not part of our notes. It might be on our assignment, but it is not part of the notes. Let me see if I can find it in the assignment. We went with add up here, add or adding or addition, yeah. I actually don't see it on your assignment either, but you will see it at some point, and I know that you've seen it before, and that word is total. If you take the total of something, you're just adding everything together. All right. So these are the 5 ones that we're going to be using for addition, or 6 for add. Add, added, adding. All right, moving on to subtraction. What words would we use for subtraction, right? Yes, difference, for sure. The difference of 2 values. We talked about that when we were adding and subtracting integers earlier on. We took the difference of the absolute values, so that would be a subtraction. What else do you see in these examples that would imply subtraction? Minus, yeah, definitely. Oftentimes, when you match up addition with subtraction, you'll see opposite words. So we've got difference could be like the opposite of sum, minus, and plus. Those are opposites. What do you think we could do for opposites of some of these other ones? Less than, yeah. More than, opposite of that would be less than. I'm going to put less than down here at the bottom. And I'm going to put an asterisk next to it. I'm going to highlight this one here because there's a very specific way that you must write when you see the words less than. And I'll talk about it as we move down this paper. But less than, it is subtraction, but it means a very specific order in which you would do that. The words often imply the order. We will talk about that in a couple minutes. Decreased by, yeah, if you have increased by, then decreased by would be the opposite of that. Excellent. And then the other one isn't really going to be an opposite of one of these. We're going to say subtracted from. Subtracted from, and that one's going to have an asterisk as well because the meaning of it, it means subtraction for sure, but it's a very specific way that it has to be written when you see subtracted from and when you see less than. So I'm just going to highlight those for now because we have to address these in a few minutes. It's one of the more confusing things and one of the things that definitely throws people off when we're writing these phrases. All right, moving on to multiplication. So we have the word product. If you look through these examples, what other words do you see that could mean multiplication? Times, yep. Definitely times. What else? Multiplied by, yes, and we can definitely do that, yeah. I'm just going to condense another line here in a minute. So multiplied by, okay, anything else? See any other words in there that would mean multiplication? What's that? Twice, yep. Twice means times 2. I'm going to put 2 other ones on this line. What's another word that could mean the same thing as twice? Squared is actually going to be a little different because that's going to be, it does mean multiplication, but because it's an exponent, it doesn't necessarily mean 2 times. It means something times itself. Or hey, double, yeah. Double would be the same thing as twice. What about multiplying by 3? What would be a word that means multiplied by 3? Times 3, or if we're dealing with like twice, double, what would be the word for times 3? Triple, yeah. So we'll put those 3 on the same line because they're all kind of very similar to one another. Twice means times 2, double means times 2, triple means times 3. And then the last one is the word of. If you see the word of implies multiplication. Okay, now division. Jorge, quotients, yes. Definitely quotients. Anything else? What's that? Half. Yes. And Gabrielle, I do see squared on number 7 there. Unfortunately, we're not actually gonna have a place on here to do that. Even though it is multiplication, it's kind of its own thing. Maybe if we did like another category for exponents, we would say squared or cubed or to the power of. What else do we see for division? We've got quotients and we have half. What about number 8? Top of the second page. Divided by. One word that I don't see very often for this, and I'm sure you haven't seen very often, would be separate. If you separate numbers, you're like pulling them apart, you're dividing them. Remain. Remainder. I would say that remainder is related to division. But it's what happens after you divide something. And I don't think we're going to be dealing with remainders with this today, but I mean, you're definitely right. Like remainders are related to division. It's not necessarily a word that means division by itself, but it certainly is attached to that meaning. The other one that I was thinking of would be third. Or 1/3, 1/2, 1/3 would be divided by 3, 1/2 would be divided by 2, 1/4, 1/5, any kind of fraction where it's like 1 and then 3rd, 4th, 10th, whatever you want to call it. All right. We've got some parentheses phrases that we're going to be dealing with as well. So parentheses phrases. You could see, let's see. I'm going to put a third one here. I'm going to do 3. The third one up top. The quantity of. I think I taught you that one yesterday. The quantity of, that implies parentheses. So let's see, times the sum of. So if something tells you it's times the sum of something else, the sum of that thing would be in parentheses. And I'll show you what that looks like. And then the other one would be times the difference of, or difference between. The difference of or the difference between. So that will imply some parentheses that we have to put in. So the words will mean like, hey, I see this word, that means the next thing I'm going to write is going to be in parentheses. So this is what I'm saying. It's definitely going to be good to have this set of notes available for you today as you're working on the assignment. It will be super helpful to have these notes on your quiz on Monday as well. So definitely make sure you're getting these all written in. All right, now turnaround phrases. Turnaround phrases mean that you're going to write things in an order that isn't quite the same. So these are going to be the 2 words that I put asterisks by up here. Less than and subtracted from. So less than. And I might even do a quick example here. So I'm going to say 4 less than X would be X minus 4. So you see what I mean by turnaround phrases? if less than, 4 less than x means x minus 4. What do you think turnaround phrase means as we look at it here? So 4 less than x translates to x minus 4. Why would that be called a turnaround phrase? Let me ask you this. Does the order of the words match the order of the expression? No, they're turned around, right? In the phrase, the number was first and then x was second, but then in the expression, x was first followed by the minus 4. That's what a turnaround phrase means. If you see the words less than, whatever number was written first is going to happen second in the expression. For example, if I were to ask you, what is 2 less than 10? What would your answer be? 8. 2 less than 10 is 8. Even though I said 2 first and I said 10 second, in your head, you still did 10 minus 2, right? So your brain will automatically do that when I give you numbers to think about. But what happens a lot of times is when I introduce variables to this, and especially when you're reading it, a lot of times when people say, okay, they'll say, all right, I've got 4 less than x, so I'm going to write 4 minus x. But that's not what the words mean. The words mean exactly what your brain just did with 2 less than 10. Flipped it around, did 10 minus 2. So that's what we're doing here. We're flipping this around and we're saying x minus 4. So that's what a turnaround phrase means. So if you see the words less than, or if you see the words subtracted from, then you know that whatever number is there and whatever variable is there in the phrase needs to be flipped around for the expression. And it would be the same type of phrase that we did with less than. So if I were to say 4 subtracted from x, it would still be x minus 4. Or if I were to say 2 subtracted from 10, you would still take 10 and subtract 2. So you're going to flip those around. Does that kind of make sense? So these two phrases, hopefully it does. These two phrases are what we're calling turnaround phrases. So if you see things written in that manner, and I'll point them out anytime we come across them in our notes here. But if you see the words less than or subtracted from, you know to flip the order that they're written in the phrase, from the phrase to the expression or in the equation. So here we go. Here are examples. The product of a number and 3. The product of a number and 3. So what does it mean by a number? Anybody know what it means by a number? The product of a number and 3. What are we going to plug in for a number? X or N or whatever. Yeah, so off to the side here, under keywords and phrases, I'm going to say a number is the variable. And your variable could be A, it could be B, it could be X, it could be N, it could be whatever, lowercase letter you want. But anytime you see a number, and I think every single one of these uses that phrasing, uses a number. So when you see a number, it could mean any number. So that's going to be your variable. So here it says the product of a number and 3. Product means what? Based on our word bank that we created, where's product at? Multiplication. So we're going to multiply a variable with 3. So that would be like 3x, 3 times x. And remember, when you write an expression with multiplication of a number and a variable, the number is going to come before the variable. So the value of the number 3 is going to come before our number, a number, which would be x. How about the difference between a number and 10? What does difference mean? Subtraction. Is this one of our turnaround phrases or not? No. So we're going to have our number minus, our variable number minus the number 10. So x minus 10. That's the difference between a number and 10. So subtraction. All right. Next one is the quotient of a number and -5. So quotient means what? Division. All right. So that would be our variable divided by -5. So you could write this 2 ways. You could say n over -5, or n divided by -5. Either way. I'm just switching from x to n. It doesn't matter what variable you choose. Okay. Next one, 4 subtracted from a number. So what operation are we using? Subtraction. Is this a turnaround phrase? Yeah. Notice that both of our turnaround phrases are with subtraction. So the only time you're going to do this specific thing is with subtraction. So instead of saying 4 minus x, we're going to flip it around and say x minus 4. Because it's a turnaround phrase, subtracted from is exactly what we saw up here. So the number, the actual value 4, is the thing that happens after the variable. So that's what it means by turnaround phrase. Flip around the order that it's written in to create your expression. All right, now we're getting a little bit more with these last two, a little bit more detailed. So it says the sum of twice a number and 7. So we're adding together twice the value of a number and 7. Sum means add, twice means what? Multiplication of what specifically? Twice means times what number? Times 2. Twice means times 2. So twice a number, so 2x, the sum of that, and 7. So we're writing 2x plus 7. We're adding together twice a number, 2x, and 7 with that. I would like you to try number 6. Try number 6 on your own. See what you get. Actually, I wrote 2 again to begin with. It should be 10 times your number plus 1. 10x plus 1, 10n plus 1. The product of a number and 10, so 10 times your variable, increased by, that was an addition word up here, increased by is addition plus 1. Any questions on those first 6 before we move on to the second page? So product of a number and 10, 10 times your variable, increased by 1 plus 1. Okay, let's move on. Number 7. All right, this one, 4 less than a number squared. So we've got 2 things happening here. What are the 2 things? What 2 things are going on here? What 2 operations? We have less than means what? Subtraction, and then squared. I'm going to circle this and I'm just going to point this out. That's an exponent. Exponent of 2. So squared means an exponent of 2. That wasn't in our word bank, so I just want to point that out. When we see less than, is that one of our turnaround subtraction phrases? Yeah. So that means that the number squared happens first, and then it's going to be minus 4. So we can say x squared minus 4. So 4 less than a number squared. All right, number 8 here, last one of our expressions, twice a number divided by 5. What does twice mean? Multiplication of 2. So twice a number, so 2x, and then divided by 5. So you can have 2x over 5, or if you want, you could do 2x divided by 5. Either way. A couple ways that we can show division. All right, now we're moving into equations. Now equations means that we will have an expression, an equal sign, and another expression. So which of these words on 10 through 16 means equals? Is, yes. So equations over here. Is means equals. That's really the only word that we're adding in that exists in every single one of these next ones that wasn't in any of the first 8. So is means equals. So the sum of twice a number and 10, the sum of twice a number and 10, so 2 times a number and 10 added together, so 2x plus 10 is equals 36. And we're not solving it, we're just writing the equation. So 2x plus 10 equals 36. The sum of twice a number and 10, twice a number, 2 times x, sum of that and 10 plus 10 is equals 36. Number 10, 3 times the difference of a number and 7 is 18. All right. So 3 times the difference of a number and 7 is 18. Now, look carefully here. So what operations do we see? I see times. What else do you see? Subtraction. However, the subtraction needs to be written how? It says times the difference of a number. We wrote something very specific when we see those words, times the difference of a number, or times the difference of. Parentheses, yes, this is one of our parentheses phrases. So 3 times the difference of a number, we can see down here, parentheses, times the difference of, that means we're gonna have parentheses. So it's gonna be 3 times, in parentheses, the difference of a number and 7 is 18. So 3 times the quantity, x minus 7, equals 18. Good morning. There you go. So this is where it gets a little bit trickier. And again, this is where it's really important to be checking your word bank on pretty much every single problem. Double check on your word bank basically every time you do one of these, because the more you check it, the more you will learn and just be like, all right, oh, I got this now. I've seen this many times. It's just one of those things with repetition, you end up kind of learning exactly what needs to happen. All right, next one, 11. 4 times a number divided by 8 is 3. All right, so 4 times a number would be what? How are we going to write that? 4 times a number. 4x divided by 8, so over 8, or divided by 8, either way, is equals 3. So 4x over 8 equals 3. All right, I want you to try 12 and 13 on your own. Be really careful with 12. Again, look very specifically on your word bank to make sure that what you've got is what it needs to be. And I'll check back in about a minute. I'm going to be pretty quick with that, and we'll check back in about a minute. Take a look for number 12 here. When you see the sum of times the sum of, that means, once again, multiplication. So that was one of our, or not multiplication, but our parentheses. So that was one of our parentheses phrases when you see times the sum of. The sum is going to be in parentheses. And then 13. 13 also has one of those kind of tricky ones in there because, let's see, you got 1/2 of a number is 8 less than the number itself. This one is going to be a little bit challenging. So have something written down, double check what we got. The word is happens a lot sooner in this one than the other one. So 1/2 of a number, so that would be like a number divided by 2, right? Because half of is division of 2. So that would be x divided by 2. There's half of a number. Is means what? 1/2 number is means what? Is means equals. So x divided by 2 equals is 8 less than. Less than means subtraction, but what kind of subtraction? The turnaround phrase with the subtraction for less than. So 8 less than the number itself. So the number itself is x minus 8 because we're switching around the order of those words there. So this one, we've got the variable that shows up twice. So that one, I think that one had a lot packed in. Okay. The product, so 14, any questions on 13 before we move on? This is stuff that's going to take some practice for sure. Use your word bank, ask questions when you need to. All right, so number 14, the product of a number and 3 is, okay, so the product of a number and 3 would just be 3 times x, right? And then is equal. So 3x equals. The product of a number and 3 is, so that's what we've done there. The same is the same, that's still part of the equals, is the same as the sum of that number and 6. The sum of that number, which is x, and 6 would be x plus 6. So that one ended up being a lot less complicated. Than the last one. Okay, here we go. 15. Number 15 says 15 decreased by. Decreased by means what? Decreased by is subtraction. Is it a turnaround phrase? Is decreased by a turnaround phrase? Do we see those exact words decreased by down on the turnaround phrases? No, we see less than, we see subtracted from. We do not see decreased by. So if we look up here, decreased by does not have an asterisk because it is not a turnaround phrase. So we're going to start with 15. So 15 decreased by, so 15 minus the quotient of a number and 3. Quotient is division. The quotient of a number and 3, x divided by 3 is equals 20. So 15 decreased by the division, the quotient of some number x and 3, x divided by 3 is equals 20. All right, 16, this is our last equation one, then we're going to move on to some inequalities. So 16 says 4 less than. So right away we see less than. Less than is a turnaround phrase. So what is it less than? It's less than the product of a number and 7. What does the product of a number and 7 look like? X times 7 or 7x, exactly. So this first part all the way up to the is a turnaround phrase. 4 less than 7x. So 7x minus 4. Up to the is, we've written that. Now is means equals. It is equal to 8 more than that number. Now this could be done either way. You could say 8 plus x or x plus 8, either way. So there's 16. All right. Make sure you have this written down. So we got 7x minus 4 equals 8 plus x. You could have equals x plus 8, that's fine. All right, so moving on to inequalities. These ones in some ways are more challenging than the rest of them, but I'm going to give you a tip. I'm going to have you ask yourself 3 simple questions as you are working through these to figure out which of the 4 inequality symbols you need to use. So first of all, less than, quick review here. Less than, that's this symbol here. Less than or equal to is the same symbol, but you have half of an equal sign underneath it. Greater than is the less than symbol, but facing the other way. Okay. And then greater than or equal to with half and equals underneath. All right. So take a look, make sure you have these 4 symbols written down, please. Have those 4 symbols written down. So we got less than or equal to, greater than, and greater than or equal to. Now, when you are going through these examples, I want you to ask yourself 3 questions. Because first of all, you're going to notice here that we're not combining, there's no operations here. I want you to notice that first of all. There's no adding, subtracting, multiplying, dividing, turnaround phrases, anything like that. It's just comparing a variable to a number. And all the words in between are going to give you one of these symbols. So ask these 3 questions. Number 1. Could it be less than? Could it be equal to? Could it be more than? So I want you to ask yourself those 3 questions every single time you write one of these, because if you actually think about it, if you say it out loud or if you think it to yourself, could this number be the same as, could it be more than that? Could it be less than that? When you get those questions answered, you'll know which of those 4 symbols to use. So could it be the same? Could it be less? Could it be more? I'm going to ask you those questions, and then I want you to ask yourself those questions as you're doing it. So a number is less than -10. So first of all, a number, that's our variable. So we're going to have x, we're going to have x, and we're going to have -10. So I want you to write x, I want you to leave a gap, I want you to write -10. Because what we're going to do is fill in the middle. We're going to fill in either a less than or equal to, greater than or equal to. So it says a number is less than -10. So could the number be less than -10? Yeah. Okay, so it's definitely less than. Could that number be the same as -10? Is it allowed to be the same as -10? No, because it says it's just less than. So that's our answer to this one. X is less than -10. Now this one's pretty straightforward because it actually uses the words less than. Not all of the words are going to use less than or equal to. It's going to use words that will imply those things. This next one doesn't though. This one again is pretty straightforward. So we've got a number, X, and then our number that we're comparing it to is 8. And then the 3 questions. Could it be less than 8? Well, yeah, it tells us that. Could it be equal to 8? Yes, it tells us that. Which means that it can't be more than 8, right? If it can't be both more than and less than. So once you determine your less than or greater than symbol, you can put that in there. And then if it could be equal to, you put the line underneath it, and you're good to go. So it could be less than, definitely. It could be the same as, could be equal to, because it just tells us that. Now the next one, again, it's pretty straightforward because it actually uses the words greater than or equal to. So a number, X, the number we're comparing it to is -4. It says that that number is greater than or equal to -4, so we're just going to write the greater than or equal to symbol. If it uses the actual words for the symbol, that's going to make life a lot easier. However, once we get to number 20, it says that a number is at most 45. Now, if something is at most 45, Could the number be less than 45? If something is at most 45, could it be less than 45? I see some nodding. Yeah, it could be, because the highest possible value is what? If it's at most 45, the highest possible value is 45, which means that it certainly could be less than 45. Is it allowed to be the same as 45? Yeah, it could be 45 as well. But it could be 45. It could also be less than 45. It cannot be more than 45. So here we're looking at x is less than or equal to 45. So if you read those words and it doesn't give you less than, greater than, less than or equal to, or greater than or equal to, ask yourself those three questions. Could this number be less than that one? Yeah, it could. Could it be the same? Definitely. How about a speed limit? A speed limit is 55 miles per hour. So if you're on the highway and the highway's speed is 55 miles an hour, are you allowed to drive under 55 miles an hour? Are you allowed to drive less than 55 miles an hour? Yeah. Are you allowed to drive exactly 55? Yes. Are you supposed to drive more than 55 miles an hour if the speed limit is 55? I mean, you can, but are you supposed to? No. Okay. So it's going to be x is less than or equal to 55 then. So those are the three questions you're asking yourself. Let's try another one. A number is at least 16. So if it's at least 16, could that number be less than 16? At least means the least value is 16. Could it be less than 16? If the smallest value is allowed to be 16, could it be under 16? It's kind of like saying, I'll give you this example here. A PG-13 movie basically means that you're not allowed to go to the movie unless you're at least 13 years old. Or your driver's license, right? You have to be at least 16 years old to get your driver's license. So at least 16, could you be 12 and get your driver's license? No, so you can't be less than 16. Could you be equal to 16? Yeah. Could you be older than 16? Yes. So we're going to say x is greater than or equal to 16. All right. I want you to try these last four on your own. Ask yourself those three questions. Could it be less than this number? Could it be the same as this number? Could it be more than this number? And that should help direct you to figuring out which symbol needs to be used. So give these a try. And I apologize for the lack of work time today, but tomorrow is going to be a work day entirely. I'll let you finish up this assignment if you need to. And then we're also going to be doing a review of the last 3 days worth of notes. So not a lot of work time today, but you have lots of work time tomorrow. So let's go ahead and take a look at these, see how you did. So for number 23, we have x is greater than or equal to 10. For 23, x is greater than or equal to 10. So a number is no less than 10. Let's listen up, please. All right, let's pause. Let's hold our conversations. Thank you. In the back. So a number is no less than 10 means that it can't be any less than 10, which means that 10 is the minimum value. So it could be more than 10. It can't be less than, it could be equal to 10. Next one, a number is no more than 26. So 26 is the absolute maximum value, which means it could be less than 26 or equal to it, but not anymore. 25, x is less than or equal to 25, and then 26, x is greater than or equal to 5. So I know that these ones can be a little bit tricky. If you get stuck, ask yourself those 3 questions. It's not the perfect method, but I think it's helpful to figure out which symbol needs to be used. So that is it for today.